Hey everybody, so in today's workout I'll be discussing how the circulatory system responds to exercise by changing heart rate, stroke volume, cardiac output, and blood pressure to meet the body's increasing demands. So during exercise, the cardiovascular system must continuously adjust to deliver oxygen and nutrients to the working muscles while removing carbon dioxide and other metabolic waste products. The harder we exercise, the greater the demand placed on the heart and blood vessels. So as I'm doing these heel taps with eccentric load on my quads, the muscles in my legs are going to require more oxygen to produce ATP. In order to meet this demand, my heart begins beating faster and pumping more blood with each contraction. And two important concepts in exercise physiology are heart rate and stroke volume. Heart rate is the number of times the heart beats each minute, while stroke volume is the amount of blood ejected by the left ventricle during a single heartbeat. During exercise, heart rate and stroke volume will increase, and this allows more oxygenated blood to reach the active skeletal muscles. Together, heart rate and stroke volume determine cardiac output, which is one of the most important measurements of cardiovascular function during exercise. And cardiac output is calculated using the equation cardiac output is equal to heart rate multiplied by stroke volume. As exercise intensity increases here, I grabbed some weights. We're doing full step-ups now. Cardiac output will also increase because both heart rate and stroke volume are elevated. For example, while resting, the heart pumps only enough blood to supply normal body functions. However, during exercise, cardiac output can increase several times above resting levels to meet the increased metabolic demands of the muscles. Another important adaptation is that, the redistribution of blood flow. As I continue these step-ups, blood vessels supplying the working leg muscles dilate, allowing greater blood flow to those tissues. And, with this increased intensity, because the exercise involves, a lot more lower body muscles, my cardiovascular system must work even harder, and heart rate continues to increase, and cardiac output rises to deliver oxygen to larger amounts of active muscle mass. Another important cardiovascular response is a change in blood pressure. So during dynamic exercises like battle ropes, systolic blood pressure increases because the heart is pumping more forcefully to deliver blood throughout the body. However, diastolic blood pressure usually changes very little because blood vessels supplying the working muscles dilate, thus reducing resistance to blood flow. This ability to regulate blood pressure while simultaneously increasing blood flow is one of the remarkable adaptations of the cardiovascular system, and these responses are coordinated by the automatic nervous system. Specifically, the sympathetic nervous system becomes more active during exercise, which is what increases our heart rate, contractility, and blood flow to muscles. These adjustments help maintain adequate oxygen delivery while supporting, continued exercise performance. And, now that we've transitioned into a recovery phase, my body's oxygen demands begin to decrease. And as a result, heart rate gradually returns towards resting levels. Stroke volume decreases and cardiac output declines. However, recovery is not immediate. It takes a little while to catch back up, and it will continue transporting oxygen to replenish energy stores while removing carbon dioxide.